We certainly will. Thank you very much, Heather. Well, as Heather mentioned there, the government is interested in whether new technology can be used to help replace artificial with organic waste like manure, slurry or digestate from anaerobic digesters. And we reported on just such a project here at Farming Today back in 2019. CCM Technologies, based in Swindon, makes pellets of fertiliser out of products like manure or digestate combined with waste carbon dioxide and ammonia from industry. Over the last 3 years, the company's taken some big steps forward, and it's now producing its pellets for commercial farm use. Pavel Kisyulevsky is their CEO.
In very simple terms, and it has to be because I'm not a chemist, we need 3 inputs. We need a waste fibre, preferably post-anaerobic digestion, because a lot of work has been done onto that fibrous material. We need CO2, the devil incarnate, and we also need a recovered ammonia source.
Let's just talk about the ammonia for a minute. Where does that come from? That's the bit that's very expensive at the moment, isn't it?
Yes, it is. And this is the key. It comes in a couple of constituent parts. One of them is that in digestate, there will be some ammonia in there. But of course, it's not stable and it's not predictable. What we're able to do is to take that inherent free ammonia, which is present in digestate in various percentages, and stabilize it and put it into a place that it can be made predictable for a specific formulation for a farmer. Now, on top of that, the second part is that we'll be seeking to source recovered ammonia, particularly from the waste treatment sector.
Using ammonia from wastewater would be a massive advantage, wouldn't it? Because then it doesn't get dumped into rivers, and it is a really problematic thing to have in watercourses.
As well as phosphorus, and we're in a position to be able to recover both of those.
Tell me how your pellets are different from just using dried out digestate or slurry.
The challenge, of course, with digestate and slurries are that one lorry load today is going to be different in terms of its nutrient and potential contaminants to next week to next month. So it is absolutely critical to be able to turn it into a predictable outcome. So the pellet will be probably on average 50% organic matter, and the remainder will be the nutrient balance that's required for whatever crop the farmer's growing. Digestate and slurries are very helpful in terms of putting organic matter on the land, but obviously the nutrients aren't specifically set up for a predictable outcome for whatever the crop is.
And when we're talking about pellets, one of the concerns around using manure is the impact on waterways and leaching out into the soil. If your pellets contain manure, then will there be the same problems, or does the fact that they're pellets make a difference?
Pellets will make a difference, but it is important to know that within the chemical reactions that bring all these inputs together is the ability to stabilize. And as we all know, fertilizer is fairly inefficient. Maybe 50% of the nutrients in a pellet will never get to the root ball of the plant in conventional materials, whereas ours are bound up in the organic matter, plus calcium carbonate, which is chalk to you and me. And that provides very significant reduction in both emissions, and we're talking 60 to 70% reductions, and also leaching and runoff, the same sort of percentages. So very significant.
It sounds very, very encouraging. Why hasn't it happened before?
Difficult to say, other than the fact that we are bringing this technology now to commercial scale. We expect to put 500 tonnes to land this growing season, i.e. March, April, and potentially a little bit of May. So it is. This moment has really arrived. That this is now being able to be done at commercial scale.
Pavel Kisyulevsky. That's all from us today. I'm Anna Hill. The studio manager is Jack Sweeney, and the producer in Bristol is Heather Simons.